Hello and welcome to this new video, which is for J277, the new exam for computer science. This video is all about trace tables. So trace tables help you to follow your way through a program, tracking the changes in variables as you go. In other words, it's a way of seeing what the computer is actually doing, what is changing in its memory as you work through a program. It's also a really useful way of testing a program to make sure there are no logic errors. So when you start to learn about the different types of errors, a logic error is something that doesn't always stand out straight away because it's not a syntax error. The program will still run, but it's not always doing exactly what you want it to do. This little example of a trace table shown on this slide is linked to this Visual Basic program on the left. Might not automatically make a lot of sense to you because you might not have used Visual Basic before, but dim_y is the same as creating a variable in Python, setting it as an integer and setting it as the value 3. So in our trace table, our first little column here for y, the first row we've put 3 in because that's its initial state in the first instance. So this is what is going on at the start. Then the next bit is starting a loop and it's saying if for loop, and we can see it's from 1 to 4. So it's going to repeat this code here 4 times. So x is 1 at the beginning, and then it goes to 2 to 3 to 4. Next to that, we've got a line of code here that we need to actually do a process. And the process is changing the variable, it's changing y. So what we need to do is y plus x. So on the second line down, we need to take what the current value of y is, which is 3, and we need to add it to the current value of x, which is 1. So therefore it becomes 4 in this box here. Then the loop will go back to the beginning again. We increment x by 1 because it's a for loop, so it increments automatically. So x then becomes 2 on this line. Then we go down a line again, and this time we are adding x to y again. X is currently 2, y is currently 4, so it becomes 6. We go back to the beginning of the loop, we increment x again, and it becomes 3. Then we add 3 to 6, which becomes 9. We go back to the beginning of the loop again, we increment x by 1 to 4. We go back down a line, we add 4 to 9 and we get 13. We go back to the beginning this time and the loop is now ended because we've already gone through the 4 iterations. And then the very last line, which it now moves down to, is console.writeLine. That is the same as print in Python, and it's going to output the existing value for y. So in our output column, 13 gets output at the end. So hopefully by the time we go through all of this video, it will be a lot easier for you to track through a trace table to understand exactly what to do. That was just a little introduction. So the main use of a trace table is to perform a run through of an algorithm to make sure there's no logic errors. As a recap, a logic error is where the program will run but does not perform as expected. The trace table usually has a column for each variable in the program. It sometimes has a column for the output as well. Each row for the trace table contains the value of the variable as you go through the program and also shows any outputs. So let's take a look at this super simple example for anyone that's struggling. Our first 3 lines here are showing our 3 variables. So if we were going to create a trace table, we need to make sure that we've got at least 3 columns to contain these 3 variables. Now we know that on line 8, obviously this is a very simple version of a login screen. So this has been created on AppLab. For line 8, obviously in the real world, this line is going to be a lot more complex. It's going to have a lot more security involved to access the database of Instagram and read through all of the different users and passwords to make sure that it's correct. Now, also, we might have some outputs in this particular program. Our output is to change a screen to a main screen or to reveal an element of access denied. There's also a little bit of processing going on in line 12, where we are increasing attempts by 1. We've also got a loop on line 5, which means that we're going to need to trace through this program and see what actually happens. Now, sometimes in the exam, you will be given particular inputs to put into this program. So at the moment, it's going to be waiting for an input from us. And until we actually input something, nothing is going to happen. So if we keep the code on the left-hand side here, I've created my truth table. So first of all, I've got my 3 variables in here: username, password, and attempts. And I've also put a column in for output. So at the beginning of the program, username is blank, password is blank, attempts has already been set as 0. So I've just put that in our first row. There's no output at the beginning. Now all of this code that is here, that is not going to run until we click the login button. So we've basically got to type our username and password in first, and then we click the button. If I input Dave and Squirrel as the username and password, you have to look at what is going to happen. So we go through. While attempts is less than 3, attempts is less than 3 because it's 0. Username equals get text, password equals get text. So this is our input, Dave and Squirrel. Dave goes in here. Squirrel goes in the next line. And they both get written to the variable to the left. So they are now assigned to the left to those 2 variables. So I've written them in here. If username equals Jonathan, no it doesn't, it equals Dave. And password equals Apple, no it doesn't, it equals Squirrel. So this is not correct, this is not true. So with an if statement, because that's not true on this line here, it's going to skip this next line of code and move down to the else statement. So we're going to run the code for the else statement, which is to show the element access denied. So I've put in the output for that, access denied, because that is what is going to happen. And on the line underneath, we add 1 to attempt. So I have added 1 to attempts and put it in as 1. Because this is a loop, it's going to go back to the beginning. Attempt is still less than 3 because it's 1. So it's going to ask us again to input the particular username and password that we want. So Dave and Squirrel are now going to get erased. And we're going to type the wrong thing in again. So this time we're going to put Joe and Orange. Now Joe and Orange are going to be written to the variables to the left. If username equals Jonathan, no, it equals Joe, and password equals Apple, no, it equals Orange. So we're going to write those in to the truth table. We know that it's wrong again, so we've added 1 to attempts, and we output access denied again. We go back to the beginning of the loop. Attempts is still less than 3 because it's 2. So this time we get one last chance to input the correct information. So this time we're going to write in the correct information to our 2 variables. So we're going to write in Jonathan, I'm just going to put John for short, and Apple. And when we've typed in those 2 particular values, they get written to the variables, then they get checked again. This time we have actually got Jonathan and it's correct. This time Apple is correct, so we move down to line 9 instead. And this time we set the screen to main. So I've put the output as go to main. So that's just a really simple truth table or trace table. And it's following through our whole program step by step, showing what will be input into that table. It allows us to make sure that this program is working correctly, so we can see that it only actually works if you type in the right information, and if it's not, then you can see that attempts is increasing and the output is like that. If I was to input something other than Jonathan and Apple, then attempts would increase to 3. It would go back to the beginning of the loop and it wouldn't run anymore. So that would be your last chance, and it's just game over. You can't input. So let's look at an example without any visual context. So this is what you're more likely to get in the exam. This is a little mini Python program. So this program here is declaring a variable called number, and we're setting it as an integer, and it's going to be an input, so we've got to wait for some sort of input from the user. We've got a loop, which is condition controlled loop, a while loop, and while the number is greater than 0, we're going to do this code which has been indented. Once that loop has finished, so when it's not true anymore, so in other words, when we are basically not greater than 0, it will print out time is up. Otherwise, it's just going to keep doing this over and over and over again. So for our table, this is another slightly different way of doing it, in the sense that I've added in which line we are looking at, and I've also added in the condition or iteration number. The reason why I've put condition or iteration is because if you've got a count controlled loop, you might know that it's going to do it 10 times. If you've got a condition controlled loop, you might be waiting to see what the condition is and whether it's been met. I've also got my output as well. For this particular program, I've only got one variable, so I've just got one column. So when I populate that table, our variable is called number. So you can see here, number is what I've written in, and the condition is that number is greater than 0. So let's start moving through this program and see what happens. So for this particular example, we are going to input the number 5. So on the exam, it will tell you what to input. We are going to put input number 5. So on line 1, we have input number 5 in here. It gets converted to an integer and gets assigned to the variable called number. So on line 1, we can put in 5 for the value of number. Then what we're going to do is we're going to move down a line and we're going to check this condition. So on line 2, we've got a variable which is number 5, and the condition that we're checking is it greater than 0? Yes, it is. So we can say that it's true. Then as our output, this is not technically output, but it helps you to trace your way through the program. We can go to line 3. So we move down a line to line 3. On line 3, we can see that we are to output the number. So whatever the current value of variable is, which is 5, we are to output it to the screen. So in the output column, we can put 5 in. Next line down is line 4. So we're on line 4 now. So I just forgot to circle that one. We're on line 4. Line 4 says number equals number minus 1. So we need to subtract 1 from whatever the variable is. So at the moment it's 5. We subtract 1 and we change it in the table to 4. Because this is part of a loop, we need to go back to line 2 again, because this is all part of this loop. So I've put my output as go to line 2, which you don't technically need, but it helps us to follow the program. So we go to line 2. Variable is still 4. We check our condition. Is it greater than 0? Yes, it is. So because it's true, we go to line 3. On line 3, we output the number. So number is 4. We output it to the screen. Move down a line. and it says to -1, so we subtract 1, which is 3. Then our output is to go to line 2 again because it's part of the loop. So when we go through this whole program until the end, your table is going to look something like this. Now I highly doubt that you will have to do all of this in the exam. One way that you could make this a lot smaller is you don't technically need to have these lines where we're talking about whether the conditions met. We could get rid of that whole column and make it a lot smaller as a table. But for the process, the idea of getting this whole process into your brain, this is my method of explaining it so that you can understand what is going on in the program. So on the previous slide, we were down to here, I think. And we've just gone down to line 2 again. So now we go to line 2, we are checking to see whether the number is greater than 0. It is, because it's 2. So we move down to line 3. We look at the number 2, we output it to the screen. We move down to line 4. We subtract our 1. We go back to line 2 because it's a loop. On line 2, we check if it's greater than 0, which it is because it's 1, which means it's true, which means we go to line 3. On line 3, we check the number, we output it, and then we move to line 4, we subtract 1, and now we're up to 0. We go to line 2. This time, line 2, while number is greater than 0, 0 is not greater than 0, so we move down to line 5, and we output time is up. I've spotted a mistake on my own thing here. This should be line 5 at the bottom. So that is a way of tracing through that algorithm, showing all of the outputs. So we can see that we've outputted 5, 4, 3, 2, 1, and time is up. A question on the exam could be, what are the outputs from this program if you input 5? You could draw your own trace table in the exam on a piece of paper, or if there's any space given to you, and you'll be able to spot what the outputs are. So here's an actual exam question. So you can see straight away that this has been basically, you would get just this table provided for you, all blank. And you can see that the table has already got the correct columns in. Gives you a much clearer idea of what's expected of you. And it's only quite a small table. So we can see that you're not going to need to go through so many steps as we just did before. It's a lot more simple than that. So on our first line, we've got x equals 15. So in our trace table, you would write in 15 on the first line. Y equals 0, so we put y as 0 on the first line as well. And at this point, there's no output. So then we're going to move down to this line here, which is the start of our loop. While x is greater than 0, now at the moment, x is 15, which is definitely greater than 0, which means we're going to do these two lines of code as part of the loop. So y is equal to y plus 1. So in our next row down, we need to basically increase y by 1. So y is currently 0. We're going to increase it to 1, which we've done. The next line is, this is really important because the value of y has now changed. So when we move down a line, it's really important that we look at the newest value in the trace table. So x is equal to x minus y. So x is currently 15, and we are subtracting the latest version of y, which is 1. So x becomes 14. Then we're going to go back to the beginning of the loop again. And we're going to check x is greater than 0, which it is. So we're going to do this line again. Y equals y plus 1. We're going to take the latest value of y and we're going to add 1 to it, so it becomes 2. Next line down, we're going to take the latest value of y and we're going to subtract it from the latest value of x. So it's 14 minus 2, which becomes 12. Another little thing that you could do is you can do a little bit of annotation down the left-hand side. It will help the examiner understand that you know what you're doing and make sure you don't make any mistakes. So you could write down the side 14 minus 2, and you can kind of keep track of what you're doing that way. We're going to go back to the beginning of the loop. X is 12, which is greater than y. So we are going to do this line, y plus 1. 2 plus 1 is 3. So we change the value of y to 3. X equals x minus y. Latest value of x is 12. Latest value of y is 3. So x becomes 9. Back to the beginning again, and we keep going. Y increases by 1. We subtract 4 from 9, it becomes 5. Back to the beginning again. 5 is still greater than 0. So y becomes 5 because we add 1. Then x becomes x minus y. X is 5, y is 5, so it becomes 0. We go back to the beginning of the loop. X is no longer greater than 0, so the program ends. So we move down to end while. And then we have our first output. Print y, so we output the current value of y to the screen, which is 5. So that's a worked through exam question. That is as likely to be kind of as difficult as you will get. Hopefully this video has helped you and you understand trace tables a lot better. If you do have any questions, don't hesitate to let me know.